Welcome to Passco Africa. Here is the question. A block of wood of mass 25.0 kilograms and volume 3.2 times 10 to the power of negative 2 m cubed floats in water. Calculate the volume of the wood above surface of the water. Now, try it yourself. To recap, we solved the question by. Visit Passco.Africa for more solutions. Subscribe for daily WASSCE prep. Welcome to Passco Africa. Here is the question. A body moves with uniform velocity if it changes its velocity by equal amounts. Now, try it yourself. To recap, we solved the question by. Visit Passco.Africa for more solutions. Subscribe for daily WASSCE prep. Welcome to Passco Africa. Here is the question. A man starts from a point A and walks a distance of 3.0 km due northeast to point B. From B he then walks 4.0 km due southeast to point X. Calculate the shortest distance between A and X. Now, try it yourself. To recap, we solved the question by. Visit Passco Africa for more solutions. Subscribe for daily WASSCE prep. Welcome to Passco Africa. Here is the question. A radioactive material of mass 80.0 g decays to 10.0 g in 6 years. Calculate its half-life. Now, try it yourself. To recap, we solved the question by. Visit Passco Africa for more solutions. Subscribe for daily WASSCE prep. Welcome to Passco Africa. Here is the question. An atom in an excited state is one whose electrons have moved to. Now, try it yourself. To recap, we solved the question by. Visit Passco.Africa for more solutions. Subscribe for daily WASSCE prep. Welcome to Passco Africa. Here is the question. An illuminated body is one which can be seen as a result of the light it. Now, try it yourself. To recap, we solved the question by. Visit Passco.Africa for more solutions. Subscribe for daily WASSCE prep. Welcome to Passco Africa. Here is the question. An object A of mass 1 kg moving at 5.0 meters per second collides head-on with an object B of mass 2.0 kg moving at 2.0 meters per second in the opposite direction. If the two objects stick together after collision, calculate their common velocity. Now, try it yourself. Step 1. Understanding the problem. We have two objects, A and B, with masses 1 kg and an unknown mass, respectively. Object A is moving at a speed of 5.0 meters per second, and object B is moving in the opposite direction with an unknown speed. The two objects are about to collide head-on. Step 2. Identifying the type of collision. Since the two objects are moving in opposite directions, we can classify this collision as an inelastic collision, assuming that the objects stick together after the collision. However, if we don't have any information about the objects sticking together, we might need to consider a different type of collision. Step 3. Applying the law of conservation of momentum. The law of conservation of momentum states that the total momentum before the collision is equal to the total momentum after the collision. Mathematically, this is represented as mv1 plus mv2 equals v, where m is the mass of an object, v is its velocity, and the subscripts 1 and 2 refer to the two objects. Step 4. Identifying given information. We are given the mass of object A, its initial velocity, and the unknown mass of object B. We need to find the unknown velocity of object B after the collision. Step 5. Applying the law of conservation of momentum. Since the two objects are moving in opposite directions, we can represent the velocities as positive and negative. Let's assume the velocity of object B is v2m/s. The equation becomes 1 kg 5.0 meters per second plus m2 equals v. Simplifying the equation, we get 5.0 kilograms m/s, m2 v2 equals v. Step 6. Solving for the unknown velocity. We can solve for v2 by isolating it on one side of the equation. However, we are missing one piece of information, the mass of object B. To proceed, we need to make an assumption or use additional information provided in the problem. Step 7. Using additional information. If we have additional information, such as the final velocity of object B, we can substitute it into the equation and solve for m2. However, since we don't have that information, we'll stop here and summarize the steps involved. To recap, we solved the question by 1. Understanding the problem. 2. Identifying the type of collision. 3. Applying the law of conservation of momentum. 4. Identifying given information. 5. Applying the law of conservation of momentum. 6. Solving for the unknown velocity. 7. Using additional information. Visit Passco.Africa for more solutions. Subscribe for daily WASSCE prep. Welcome to Passco Africa. Here is the question. As the source of sound approaches a stationary observer, the frequency appears to increase. This phenomenon is called. Now, try it yourself. To recap, we solved the question by. Visit Passco.Africa for more solutions. Subscribe for daily WASSCE prep. Welcome to Passco Africa. Here is the question. Calculate the quantity of heat needed to melt 4.0 kilograms of ice at 0 degrees C and to raise the temperature of the water formed to 50 degrees Celsius. Now, try it yourself. Step 1. Identify the given information. To begin, we need to identify the given information in the problem statement. We are asked to calculate the quantity of heat needed to melt 4.0 kilograms of ice at 0 degrees Celsius and to raise the temperature of the resulting water to 100 degrees Celsius. Given information: mass of ice equals 4.0 kilograms, initial temperature of ice equals 0 degrees Celsius, final temperature of water equals 100 degrees Celsius, specific latent heat of fusion of ice equals 334 J/G, specific heat capacity of water equals 4.184 J/G degrees C. Step 2. Understand the process of melting ice. To melt ice, we need to apply heat energy to overcome the intermolecular forces holding the ice crystal together. The specific latent heat of fusion is the amount of heat energy required to change a unit mass of a substance from solid to liquid state at its melting point. Step 3. Calculate the heat energy required to melt the ice. To calculate the heat energy required to melt the ice, we use the formula Q equals mL, where Q is the heat energy, m is the mass of ice, and L is the specific latent heat of fusion. Python Q equals 4.0 kilograms 334 J/G 1000 G/kg equals 1,336,000 G. Step 4. Understand the process of raising the temperature of water. To raise the temperature of water, we need to apply heat energy to increase the kinetic energy of the water molecules. The specific heat capacity is the amount of heat energy required to change the temperature of a unit mass of a substance by 1 degree Celsius. Step 5. Calculate the heat energy required to raise the temperature of water. To calculate the heat energy required to raise the temperature of water, we use the formula Q equals mc delta T, where Q is the heat energy, m is the mass of water, c is the specific heat capacity, and delta T is the change in temperature. In this case, the change in temperature is the difference between the final temperature and the initial temperature, which is 100 degrees Celsius. Python Q equals 4.0 kilograms 4.184 J/G degrees C 100 degrees Celsius 1000 G/kg equals 1,670,400 J. Step 6. Calculate the total heat energy required. To calculate the total heat energy required, we add the heat energy required to melt the ice and the heat energy required to raise the temperature of water. Python total Q equals Q plus Q equals 1,336,000 J plus 1,670,400 J equals 3,006,400 J. Step 7. Convert the answer to the required units. The answer should be in the units of joules. Since the answer is already in joules, no conversion is necessary. To recap, we solved the question by 1. Identify the given information. 2. Understand the process of melting ice. 3. Calculated the heat energy required to melt the ice. 4. Understand the process of raising the temperature of water. 5. Calculated the heat energy required to raise the temperature of water. 6. Calculated the total heat energy required. 7. Convert the answer to the required units. Visit Passco.Africa for more solutions. Subscribe for daily WASSCE prep. Welcome to Passco Africa. Here is the question. Lost volts is the voltage read on the voltmeter. Now, try it yourself. To recap, we solved the question by. Visit Passco.Africa for more solutions. Subscribe for daily WASSCE prep. Welcome to Passco Africa. Here is the question. The first position of resonance in a resonance tube is 18.0 cm from the open end. Neglecting end correction, calculate the distance from the open to the next position of resonance. Now, try it yourself. To recap, we solved the question by. Visit Passco.Africa for more solutions. Subscribe for daily WASSCE prep. Hello, students. Welcome to this educational video on physics, specifically the function of capacitors in rectifier circuits. This is a crucial topic for the WASSCE/WAEC exams, and I'm here to break it down in a simple and easy to understand manner. As you know, capacitors are essential components in electronic circuits, and their role in rectifier circuits is no exception. In this video, we'll explore the importance of capacitors in rectifier circuits and how they help improve the performance of these circuits. Here is the question. The function of the capacitor in a rectifier circuit is to. Now, try it yourself. To recap, we solved the question by. Visit Passco.Africa for more solutions. Subscribe for daily WASSCE prep. Welcome to Passco Africa. Here is the question. The magnetic field around the double back currents is triple. Now, try it yourself. Step 1. Understanding the double helix currents. Narrator. A double helix current is a type of electric current that flows through a double helix-shaped wire. This configuration is commonly used in applications such as loudspeakers and headphones. Step 2. Magnetic field around a current-carrying wire. Narrator. We know that a current-carrying wire generates a magnetic field around it. This magnetic field is given by the formula, B equals / where B is the magnetic field strength, mu is the magnetic constant, I is the current flowing through the wire, and I is the distance from the wire. Step 3. Magnetic field around a double helix current. Narrator. For a double helix current, we can use the Biot-Savart law to calculate the magnetic field at any point. However, due to the complexity of the derivation, we will focus on the key concept rather than the mathematical derivation. Step 4. Key concept, magnetic field lines. Narrator. The magnetic field lines around a double helix current are similar to those around a single wire. The key concept to remember is that the magnetic field lines form concentric circles around the wire. Step 5. Applying the concept to the exam. Narrator. When applying this concept to your exam, make sure to remember the following. The magnetic field strength is directly proportional to the current flowing through the wire. The magnetic field strength decreases with increasing distance from the wire. The direction of the magnetic field lines can be determined using the right-hand rule. Step 6. Example question. Narrator. Here's an example question. A double helix current carries a current of 2A. What is the magnetic field strength at a distance of 5 cm from the wire? A. 0.2 TB, 0.40 C, 0.60 D, 0.80. To solve this question, you can use the formula, B equals / plug in the values. We get B equals / B equals 0.40, so the correct answer is B, 0.40. Step 7. Conclusion. Narrator. In conclusion, the magnetic field around a double helix current is similar to that around a single wire. The key concept to remember is that the magnetic field lines form concentric circles around the wire. Make sure to practice applying this concept to different scenarios in your exam. Pro tip: always use the formula B equals / to calculate the magnetic field strength. With practice and dedication, you will master this topic and excel in your WASSCE Physics exam. To recap, we solved the question by 1. Understanding the double helix currents, 2. Magnetic field around the current carrying wire, 3. Magnetic field around the double helix currents, 4. Key concept, magnetic field lines, 5. Applying the concept to the exam, 6. Example question, 7. Conclusion. Visit Passco Africa for more solutions. Subscribe for daily WASSCE prep. Welcome to Passco Africa. Here is the question. The nuclear binding energy of an atom is the energy needed. Now, try it yourself. To recap, we solved the question by. Visit Passco Africa for more solutions. Subscribe for daily WASSCE prep. Welcome to Passco Africa. Here is the question. The pressure on the base of an open cylinder containing a liquid does not depend on height. Now, try it yourself. Step 1. Understand the concept of pressure. Pressure is defined as the force exerted per unit area on an object. Mathematically, this can be represented as P equals F/A. Step 2. Identify the forces acting on the liquid. In an open cylinder, there are two main forces acting on the liquid: the weight of the liquid itself and the atmospheric pressure exerted on the surface of the liquid. Step 3. Calculate the weight of the liquid. The weight of the liquid can be calculated using the formula W equals rho Vg, where rho is the density of the liquid, V is the volume of the liquid, and G is the acceleration due to gravity. Step 4. Calculate the atmospheric pressure. Atmospheric pressure can be calculated using the formula P equals rho Gh, where rho is the density of air, G is the acceleration due to gravity, and H is the height of the column of air. Step 5. Combine the forces. Since the forces acting on the liquid are perpendicular to each other, we can use the Pythagorean theorem to combine them. This results in a new force that acts on the base of the cylinder. Step 6. Calculate the pressure on the base. Using the combined force calculated in Step 5, we can now calculate the pressure on the base of the cylinder using the formula P equals F/A. Step 7. Simplify the expression. After substituting the values, we can simplify the expression to obtain the final answer. To recap, we solved the question by 1. Understand the concept of pressure. 2. Identify the forces acting on the liquid. 3. Calculated the weight of the liquid. 4. Calculated the atmospheric pressure. 5. Combined the forces. 6. Calculated the pressure on the base. 7. Simplified the expression. Visit Passco.Africa for more solutions. Subscribe for daily WASSCE prep. Welcome to Passco Africa. Here is the question. The speed of light in air and water are 3.0 x 10⁻8 ms, 1 and 2.25 x 10⁻8 ms-1 respectively. Calculate the critical angle for water when light travels from water to air. Now, try it yourself. Step 1. Understanding the basics of light speed. The speed of light in a vacuum is a fundamental constant in physics, denoted by c, and has a value of approximately 3.0 multiplied by 10 to the power of 8 meters per second. However, when light travels through a medium like air or water, its speed is affected. Step 2. The concept of refractive index. The refractive index of a medium is a measure of how much it bends light as it passes through it. The refractive index of air is approximately 1.00, while that of water is approximately 1.33. Step 3. The formula for speed of light in a medium. The speed of light in a medium can be calculated using the formula V equals c/n, where V is the speed of light in the medium, c is the speed of light in a vacuum, and n is the refractive index of the medium. Step 4. Calculating the speed of light in air. Using the formula above, we can calculate the speed of light in air as follows: V equals c/n equals /1.00 is equal to 3.0 multiplied by 10 to the power of 8 m/s. Step 5. Calculating the speed of light in water. Similarly, we can calculate the speed of light in water as follows: water equals c/water equals /1.33 is equal to 2.25 multiplied by 10 to the power of 8 m/s. Step 6. Understanding the significance of the results. The results show that the speed of light in water is approximately 25% less than its speed in air. This is due to the higher refractive index of water, which bends light more than air does. Step 7. Implications for the WASSCE exam. In the WASSCE exam, you may be asked to calculate the speed of light in different mediums or to use the concept of refraction to solve problems. Make sure to understand the basics of light speed and refractive index, and practice using the formula to calculate the speed of light in different mediums. To recap, we solved the question by 1. Understanding the basics of light speed, 2. The concept of refractive index, 3. The formula for speed of light in a medium, 4. Calculating the speed of light in air, 5. Calculating the speed of light in water, 6. Understanding the significance of the results, 7. Implications for the WASSCE exam. Visit Passco.Africa for more solutions. Subscribe for daily WASSCE prep. Welcome to Passco Africa. Here is the question. The vigorous sparks produced on the discharge of a capacitor shows that. Now, try it yourself. To recap, we solved the question by. Visit Passco.Africa for more solutions. Subscribe for daily WASSCE prep. Welcome to Passco Africa. Here is the question. Two brass spheres mounted on an insulator may be charged by induction by the following procedures: A negative. Why charged rod is brought near one of the spheres 2. The spheres are brought into contact with each other 3. The charged rod is moved further away 4. The two spheres are separated. Which of the following is the correct sequence of the charging process? Now, try it yourself. To recap, we solved the question by. Visit Passco.Africa for more solutions. Subscribe for daily WASSCE prep. Welcome to Passco Africa. Here is the question. 2 points A and B are conjugate with respect to a converging lens. If A and B are 20.0 cm and 16.0 cm respectively from each principal focus, calculate the focal length of the lens. Now, try it yourself. To recap, we solved the question by. Visit Passco Africa for more solutions. Subscribe for daily WASSCE prep. Welcome to Passco Africa. Here is the question. What energy transformation occurs in a hydroelectric plant? Now, try it yourself. To recap, we solved the question by visit Passco Africa for more solutions. Subscribe for daily WASSCE prep. Hello and welcome to this educational video on physics, specifically focusing on the experimental setup for the determination of elevation of a liquid column. In this video, we will be exploring the purpose of the stirrer in this setup and its importance for your WASSCE/WAEC exams. The determination of elevation of a liquid column is a fundamental concept in physics, and understanding the experimental setup is crucial for any student pursuing a career in scientific research or engineering. The stirrer is a critical component of this setup, and its purpose is to ensure that the liquid is mixed thoroughly and consistently during the experiment. Here is the question. What is the purpose of the stirrer in the experimental setup for the determination of specific heat capacity of liquid by the method of mixtures? Now, try it yourself. To recap, we solved the question by. Visit Passco.Africa for more solutions. Subscribe for daily WASSCE prep. Welcome to Passco Africa. Here is the question. Which of the following best explains the rease resistance of a pure metal with NSMG temperature? Now, try it yourself. Step 1. What is resistance? Resistance is a measure of the opposition to the flow of electric current through a conductor. It is denoted by the symbol A and measured in ohms. Step 2. The relationship between temperature and resistance. When a pure metal is heated, its atoms gain kinetic energy and start vibrating more rapidly. These vibrating atoms collide with each other, creating more resistance to the flow of electric current. The temperature coefficient of resistance is a measure of how much the resistance of a metal increases with temperature. Step 3. The formula for resistance. The resistance of a conductor is given by the formula I equals ρL/A, where ρ is the resistivity of the material, which depends on the temperature. L is the length of the conductor. A is the cross-sectional area of the conductor. Step 4. The relationship between resistivity and temperature. The resistivity of a pure metal is directly proportional to the temperature, as expressed by the formula ρ equals ρ0, where ρ0 is the resistivity at 0 degrees Celsius. Alpha is the temperature coefficient of resistance. T is the temperature in degrees Celsius. Step 5. Understanding the temperature coefficient of resistance. The temperature coefficient of resistance is a measure of how much the resistance of a metal increases with temperature. It is typically denoted by a positive value, indicating that the resistance increases with temperature. Step 6. Analyzing the effect of temperature on resistance. When a pure metal is heated, its resistivity increases, leading to an increase in resistance. This is due to the increased collisions between the vibrating atoms, which opposes the flow of electric current. Step 7. Applying the concepts to real-world scenarios. Understanding the relationship between temperature and resistance is crucial in real-world applications, such as designing electrical circuits and thermometry systems. To recap, we solved the question by 1. What is resistance? 2. The relationship between temperature and resistance. 3. The formula for resistance. 4. The relationship between resistivity and temperature. 5. Understanding the temperature coefficient of resistance. 6. Analyzing the effect of temperature on resistance. 7. Applying the concepts to real-world scenarios. Visit Passco.Africa for more solutions. Subscribe for daily WASSCE prep. Welcome to Passco Africa. Here is the question. Which of the following are correct about both uniform circular motion and simple harmonic motion? I. Acceleration is directed towards a fixed point. 2. Motion has periodic time. Il. Acceleration is constant. Now, try it yourself. To recap, we solved the question by. Visit Passco.Africa for more solutions. Subscribe for daily WASSCE prep. Welcome to Passco Africa. Here is the question. Which of the following are safety precautions in a household wiring system? I. Switches are placed on the live wire of the mains. 2. Plugs have 3 pins with one earthling the casing on the appliance. 3. Fuse wires are used in fuse boxes. 4. Wires are covered with insulating materials. Now, try it yourself. Step 1. Regular maintenance. Regular maintenance is key to preventing electrical hazards. Check your wiring system regularly for any signs of damage, wear, and tear. Look for frayed cords, loose connections, and broken switches. Step 2. Use the right materials. Use high-quality materials for your wiring system. Copper wiring is a popular choice due to its high conductivity and durability. Avoid using aluminum wiring, which can cause fires. Step 3. Avoid overloading. Avoid overloading your electrical outlets and circuits. This can lead to overheating, which can cause fires. Use the correct gauge of wire for your electrical load. Step 4. Grounding. Grounding is essential for preventing electrical shocks. Make sure your wiring system is properly grounded. This involves connecting the neutral wire to the grounding rod. Step 5. Use fuses or circuit breakers. Use fuses or circuit breakers to prevent overloading and electrical shocks. Fuses and circuit breakers act as safety switches that trip when the electrical load exceeds a certain limit. Step 6. Avoid water and electricity. Avoid exposing your electrical wiring to water. This can cause electrical shocks and even lead to electrocution. Keep your electrical wiring away from sinks, bathtubs, and toilets. Step 7. Hire a licensed electrician. If you're not sure about any aspect of your household wiring system, hire a licensed electrician. They can ensure that your wiring system is safe and meets the necessary standards. To recap, we solved the question by 1. Regular maintenance, 2. Use the right materials, 3. Avoid overloading, 4. Grounding, 5. Use fuses or circuit breakers, 6. Avoid water and electricity, 7. Hire a licensed electrician. Visit Passco Africa for more solutions. Subscribe for daily WASSCE prep. Welcome to Passco Africa. Here is the question. Which of the following graphs represents the inductive reactance exploited against frequency f for an LCR series circuit? Now, try it yourself. Step 1. Understanding inductive reactance. Inductive reactance is the opposition to the change in current in an inductor. It's measured in ohms and depends on the inductance of the coil and the frequency of the alternating current. Step 2. Formula for inductive reactance. The formula for inductive reactance is given by X equals 2 pi FL, where X is the inductive reactance, F is the frequency of the AC, and L is the inductance of the coil. Step 3. Relationship between X and frequency. From the formula, we can see that inductive reactance is directly proportional to the frequency of the AC. This means that as the frequency increases, the inductive reactance also increases. Step 4. Graphical representation. To represent this relationship graphically, we can plot inductive reactance against frequency. The resulting graph will be a straight line passing through the origin, with a positive slope. Step 5. Eliminating incorrect options. To identify the correct graph, let's analyze the options. Option A, a graph with a negative slope, representing an inverse relationship between X and F. This is incorrect, as X is directly proportional to F. Option B, a graph with a positive slope, but passing through a non-zero y-intercept. This is also incorrect, as the y-intercept should be 0. Option C, a graph with a negative y-intercept. This is incorrect, as the y-intercept should be 0. Option D, a graph with a positive slope, passing through the origin. This is the correct graph. Step 6. Understanding the implications. The relationship between inductive reactance and frequency has significant implications in the design of electrical circuits. For example, in a resonant circuit, the inductive reactance and capacitive reactance are equal, resulting in a maximum current. Understanding this relationship is crucial for designing such circuits. To recap, we solved the question by 1. Understanding inductive reactance, 2. Formula for inductive reactance, 3. Relationship between multiplied by and frequency, 4. Graphical representation, 5. Eliminating incorrect options, 6. Understanding the implications. Visit Passco.Africa for more solutions. Subscribe for daily WASSCE prep. In our daily lives, we often find ourselves in situations where we need to observe objects or people from a distance. However, when we're underwater, like in a submerged submarine, our line of sight is limited by the density of water and the surrounding pressure. To overcome this challenge, we need to rely on specialized instruments designed to aid our vision in such situations. In this video, we'll explore the instrument that a man in a submerged submarine would use to view a boat on the sea. Here is the question. Which of the following instruments would a man in a submerged submarine use to view a boat on the sea? Now, try it yourself. Step 1. Understanding the basics. Periscopes are optical devices used to see objects that are not in direct line of sight. They use a combination of mirrors and lenses to redirect light and create an image of the object being observed. Step 2. The principle of refraction. Periscopes rely on the principle of refraction, which states that light bends when passing from one medium to another. In this case, light travels from the water into the air and then into the periscope, causing it to bend and create an image. Step 3. The role of mirrors and lenses. Periscopes use a combination of mirrors and lenses to redirect light and create an image. The mirrors are used to reflect the light, while the lenses are used to focus the image. Step 4. Creating an image. When light enters the periscope, it is reflected by the mirrors and focused by the lenses. This creates an image of the object being observed, which is then viewed by the person inside the submarine. Step 5. The importance of angular perspective. The periscope allows the person inside the submarine to view the boat from a different angular perspective. This is crucial for navigation and surveillance purposes. Step 6. The science behind the periscope. The periscope works on the principles of optics and geometry. The mirrors and lenses are carefully designed to create a clear and magnified image of the object being observed. Step 7. Real-world applications. Periscopes have various real-world applications, including in submarines, telescopes, and binoculars. They play a crucial role in observation and surveillance. To recap, we solved the question by 1. Understanding the basics, 2. The principle of refraction, 3. The role of mirrors and lenses, 4. Creating an image, 5. The importance of angular perspective, 6. The science behind the periscope, 7. Real-world applications. Visit Passco.Africa for more solutions. Subscribe for daily WASSCE prep. Welcome to Passco Africa. Here is the question. Which of the following is correct about the fixed points of a temperature scale? Now, try it yourself. Step 1. Definition of fixed points. Fixed points are specific temperatures that are used as reference points to define the scale. These points are chosen because they are reproducible and can be easily measured. Step 2. Significance of fixed points. The fixed points of a temperature scale are crucial for ensuring that measurements are consistent and reliable. They provide a basis for calibrating thermometers and other temperature measuring instruments. Step 3. Definition of the Celsius scale. The Celsius scale is a temperature scale that uses the freezing and boiling points of water as its fixed points. The freezing point of water is defined as 0 degrees Celsius, and the boiling point is defined as 100 degrees Celsius. Step 4. Mathematical expression of temperature. Temperature is a measure of the average kinetic energy of the particles in a substance. It can be expressed mathematically using the following formula: T equals mv², where m is the mass of the particle, and v is its velocity. Step 5. Relationship between temperature and kinetic energy. As the temperature of a substance increases, the average kinetic energy of its particles also increases. This is because the particles have more energy to move and vibrate. Step 6. Expression of temperature in Kelvin. In the Kelvin scale, the fixed points are defined as 273.15 K for the freezing point of water and 373.15 K for the boiling point. The Kelvin scale is an absolute temperature scale, meaning that it has a true 0 point. Step 7. Conversion between temperature scales. To convert temperature from Celsius to Kelvin, you can use the following formula: T equals T plus 273.15. Conversely, to convert temperature from Kelvin to Celsius, you can use the following formula: T equals T 273.15. To recap, we solved the question by 1. Definition of fixed points, 2. Significance of fixed points, 3. Definition of the Celsius scale, 4. Mathematical expression of temperature, 5. Relationship between temperature and kinetic energy, 6. Expression of temperature in Kelvin, 7. Conversion between temperature scales. Visit Passco.Africa for more solutions. Subscribe for daily WASSCE prep. Welcome to Passco Africa. Here is the question. Which of the following is not a simple machine? Now, try it yourself. To recap, we solved the question by. Visit Passco.Africa for more solutions. Subscribe for daily WASSCE prep. Welcome to Passco Africa. Here is the question. Which of the following is not an example of motion under constant acceleration? Now, try it yourself. To recap, we solved the question by. Visit Passco.Africa for more solutions. Subscribe for daily WASSCE prep. Welcome to Passco Africa. Here is the question. Which of the following is the reason for banking of racing tracks? Now, try it yourself. Step 1. Understanding the concept of banking. Banking of racing tracks involves tilting the track at an angle to facilitate faster speeds. This is achieved by creating a centripetal force that helps the vehicle move in a circular path. Step 2. Identifying the forces involved. There are two main forces involved in banking of racing tracks, the force of gravity and the centripetal force. The force of gravity pulls the vehicle towards the center of the Earth, while the centripetal force is directed towards the center of the circular path. Step 3. Understanding the relationship between speed, banking angle, and radius. The banking angle is related to the speed of the vehicle, the radius of the circular path, and the acceleration due to gravity. The formula for this relationship is tan equals v squared slash. Step 4. Deriving the formula for banking angle. To derive the formula for the banking angle, we use the concept of centripetal force and equate it to the force of gravity. Rearranging the equation, we get mg equals m backslash v squared slash a. Dividing both sides by mg, we get 1 slash a equals v squared slash multiplying both sides by a, we get a equals g backslash a slash v squared. Now, dividing both sides by g, we get a slash g equals a slash v squared. Multiplying both sides by v squared, we get v squared backslash a slash g equals a. Now, dividing both sides by a, we get v squared slash g equals 1. Now, taking the square root of both sides, we get v slash sqrt equals sqrt. Multiplying both sides by sqrt, we get v equals sqrt. Now, substituting the equation for v in the equation for the banking angle, we get tan equals 2 slash. Simplifying the equation, we get tan equals g slash. Now, dividing both sides by g, we get tan equals 1 slash a. Now, multiplying both sides by a, we get a backslash tan equals a. Now, dividing both sides by a, we get tan equals 1. Now, we can substitute the value of theta in the equation for the banking angle, theta equals arctan. Simplifying the equation, we get theta equals pi slash 4. Step 5. Understanding the role of speed in banking. The speed of the vehicle has a significant impact on the banking angle required for a given radius of the circular path. As the speed increases, the banking angle also increases to maintain the circular motion. Step 6. Applying the concept to racing tracks. The concept of banking of racing tracks is widely used in motor racing to achieve greater speeds. The banking angle is carefully designed to ensure that the vehicle can maintain a stable circular motion at high speeds. Step 7. Conclusion. In conclusion, the banking of racing tracks is a technique used to achieve greater speeds by creating a centripetal force that helps the vehicle move in a circular path. The banking angle is related to the speed of the vehicle, the radius of the circular path, and the acceleration due to gravity. Understanding the principles of banking of racing tracks is crucial for your WASSCE exams, and I hope this video has helped you grasp the concept. To recap, we solved the question by 1. Understanding the concept of banking, 2. Identifying the forces involved, 3. Understanding the relationship between speed, banking angle, and radius, 4. Deriving the formula for banking angle, 5. Understanding the role of speed in banking, 6. Applying the concept to racing tracks, 7. Conclusion. Visit Passco.Africa for more solutions. Subscribe for daily WASSCE prep. Welcome to Passco Africa. Here is the question. Which of the following is the reason for banking of racing tracks? Now, try it yourself. To recap, we solved the question by Visit Passco.Africa for more solutions. Subscribe for daily WASSCE prep. Welcome to Passco Africa. Here is the question. Which of the following is the unit of work? Now, try it yourself. To recap, we solved the question by. Visit Passco Africa for more solutions. Subscribe for daily WASSCE prep. Welcome to our physics tutorial series, where we break down complex concepts into simple, understandable pieces. Today, we are going to explore one of the fundamental properties of a liquid, its boiling point. This is an essential topic in the WASSCE syllabus, and understanding it will help you score better in your exams. So, let's dive right in. Here is the question. Which of the following occurs at the boiling point of a liquid? Now, try it yourself. To recap, we solved the question by. Visit Passco Africa for more solutions. Subscribe for daily WASSCE prep. Welcome to Passco Africa. Here is the question. Which of the following occurs in the charging of an accumulator? Now, try it yourself. To recap, we solved the question by. Visit Passco Africa for more solutions. Subscribe for daily WASSCE prep. Welcome to Passco Africa. Here is the question. Which of the following relations between the force F and the distance r satisfies the law of gravitation? Now, try it yourself. To recap, we solved the question by. Visit Passco Africa for more solutions. Subscribe for daily WASSCE prep. Welcome to our physics tutorial series for WASSCE. In this video, we'll be discussing one of the fundamental concepts in nuclear physics, the radioactive decay law. This topic is crucial for your exams, as it appears in both theory and practical papers. By the end of this video, you'll understand the assumptions behind the radioactive decay law and be able to apply it to solve problems. Here is the question. Which of the following statements is an assumption of the radioactive decay law? Now, try it yourself. Step 1. The decay process is random. The decay of a radioactive atom is a random and spontaneous process. This means that the probability of decay does not depend on the external conditions, such as temperature or pressure. Step 2. The decay process is independent. The decay of one radioactive atom does not affect the decay of other atoms. This is because the decay process is a random and spontaneous event. Step 3. The decay process is uniform. The decay rate of a radioactive substance is uniform throughout its sample. This means that the decay rate is the same for all atoms in the sample. Step 4. The decay constant is constant. The decay constant is a constant that depends on the radioactive substance. It is a fundamental property of the substance and does not change over time. Step 5. The sample size is large enough. The sample size must be large enough to ensure that the decay process is representative of the entire population. This means that the sample size should be much larger than the number of atoms that decay per unit time. Step 6. The decay process is not affected by external factors. The decay process is not affected by external factors such as temperature, pressure, or radiation from other sources. Step 7. The decay process is a first-order process. The decay process is a first-order process, meaning that the rate of decay is directly proportional to the number of radioactive atoms present. To recap, we solved the question by 1. The decay process is random. 2. The decay process is independent. 3. The decay process is uniform. 4. The decay constant is constant. 5. The sample size is large enough. 6. The decay process is not affected by external factors. 7. The decay process is a first-order process. Visit Passco.Africa for more solutions. Subscribe for daily WASSCE prep. Welcome to Passco Africa. Here is the question. Which of the following statements is not correct about photoelectric emission? Now, try it yourself. Step 1. Understanding photoelectric emission. Photoelectric emission is the process by which light hitting a metal surface causes electrons to be emitted from the surface. This phenomenon was first observed by Heinrich Hertz in the late 19th century. The kinetic energy of the emitted electrons depends on the energy of the incident light. Step 2. Einstein's photoelectric equation. Einstein's photoelectric equation explains the relationship between the energy of the incident light and the kinetic energy of the emitted electrons. The equation is given by EC equals hf, W, where EC is the kinetic energy of the electrons, h is Planck's constant, f is the frequency of the incident light, and W is the work function of the metal surface. Step 3. Work function and threshold frequency. The work function is the minimum energy required to remove an electron from the metal surface. The threshold frequency is the minimum frequency of light required to overcome the work function. When the frequency of the incident light is greater than the threshold frequency, photoelectric emission occurs. Step 4. Mathematical derivation of threshold frequency. To find the threshold frequency, we can rearrange Einstein's photoelectric equation to get F0 equals W/h. This equation shows that the threshold frequency is inversely proportional to Planck's constant. Step 5. Factors affecting photoelectric emission. Several factors affect photoelectric emission, including the intensity of the incident light, the frequency of the light, and the work function of the metal surface. Increasing the intensity of the light increases the number of emitted electrons, while increasing the frequency of the light increases the kinetic energy of the electrons. Step 6. Correct answer. Now, let's get to the question. Which of the following statements is not correct about photoelectric emission? A. The kinetic energy of the emitted electrons depends on the energy of the incident light. B. The work function is the minimum energy required to remove an electron from the metal surface. C. Increasing the intensity of the light increases the work function. D. The threshold frequency is the minimum frequency of light required to overcome the work function. The correct answer is C. Increasing the intensity of the light increases the work function. Step 7. Conclusion. In conclusion, photoelectric emission is a fundamental phenomenon in physics that explains how light interacts with matter. The kinetic energy of the emitted electrons depends on the energy of the incident light, and the work function is the minimum energy required to remove an electron from the metal surface. Remember, the threshold frequency is the minimum frequency of light required to overcome the work function. This concept is crucial for your WASSCE physics exams, so make sure to practice and understand it well. To recap, we solved the question by 1. Understanding photoelectric emission, 2. Einstein's photoelectric equation, 3. Work function and threshold frequency, 4. Mathematical derivation of threshold frequency, 5. Factors affecting photoelectric emission, 6. Correct answer, 7. Conclusion. Visit Passco Africa for more solutions. Subscribe for daily WASSCE prep.